Yeah, so the center of our circle could be a point, and our radius could be, let's say that it's a length like this. If this is my center, our radius could go all the way around at the same distance. So if this is a length of 2, then our radius could go down 2, it could go left 2, it could go up 2, right? It could go any direction, right? And it goes infinitely around the center of a circle. So if you can imagine, it's going to go infinitely around the whole circle, right? So I could draw a circle based upon the radius going all the way around these points. Okay, so that's what we're working on today, all right? So, and we use this all the time. Circles are super important. You see them on your car, right? Where do you have circles? On the wheels, right? We use them. Let's say anyone want to maybe have a house or a home one day and want a jacuzzi in that house? Okay. What happens, or you might want to install a gazebo or something. Usually those are, a jacuzzi or a gazebo is usually in the shape of a circle. Shh, please quiet down. So, your backyard could be a graph, right? And you want to put a jacuzzi in. There are limits to what you could use or where you could put it because the city has codes that says it has to be at least this far from a wall, has to be at least this far from the house. It can't be this small, it has to be at least this big, and it can't be too big, so you have to think about the radius and the position of your jacuzzi. Okay? So, here are the steps for today. Turn to your neighbor, and I want you to identify any similarities here to this equation and maybe something we've already worked on in math, okay? Take a moment. Go. What do you notice that's similar here? What do we notice that's a similarity here? I heard some people say it.
It's the equation of a circle.
I know it's the equation of a circle. What's similar here?
It's like geometry.
What is similar? Yeah. What? They're all being squared. What other things do you notice that are similar? What else is being similar? Okay, what's being subtracted there? It's not a trick question. What do you see that looks familiar to you? Aaron, what was that? H and K, good. You all see H and K there?
Yeah.
Okay, don't be afraid of answering. That's okay. So what do H and K do to a graph? They move it left and right or up and down, right? Remember that whole thing? We did that with absolute value. We did it with logarithmic equations, exponential equations. Okay? So, it's called translating. What's it called when we move a graph around? Translating. Okay, good. Okay, so right now, just pencils down. I'll show you numbers 1 and 2, and then we will we'll have you write, okay? So eyes up here, pencils down. So number 1, it says identify the center, radius, and then graph. So we got 1 is 2. Or x minus 2 squared is plus y plus 2 squared is equal to 4. So I already recognize this as the standard form of the equation. And so I recognize that this is the standard form. So we have h and k's already there. So I know this is x minus h. So if this is my h, then I know that this is going to be x, or h is going to be equal to 2. Over here we got y plus 2 squared is equal to 4. So we know that's supposed to be y minus k, except that in this case we have a plus sign, so I can make a plus sign by pretending that it's negative 2. So it's like y minus a negative 2. So our k is equal to negative 2. Our r squared is equal to 4. If I wanted to solve for r, just take the square root of both sides. Square root of 4 is 2, right? So if this is the case, if r is equal to 2 and our h and k are 2 and negative 2, then I can make that my center. Okay? And I could plot my center and plot my radius. Okay, so 2, negative 2. I'm going to plot my center right here. Okay, our radius is 2, so we're going to go up 2 from the center, right 2 from the center, down 2 from the center, and left 2 from the center. And we're going to draw a circle around, touching all these points as well as we can. If we have a compass, it'd be a lot easier. On the iPad, it does a little automatic circle thing, but it's really hard to center it. Anyways, that's how we do number 1. So what did I do again? Step 1 says identify the parts of the standard equation of a circle. So I identified what h and k were and my radius. 2, I identified the center, which was 2, -2. Radius is 2. Plotted my point at the center, went up 2, right 2, down 2, and left 2. Because it should always be the same, right? And that's my circle, right? Number 2. Number 2 looks a little bit more difficult because it says x squared plus y minus 1 squared is equal to 25. It doesn't look like there's an h there, but when there's nothing there, or what represents nothing? 0. So I could say that this is like saying x minus 0 squared, right? Would you agree with that? Does this change anything if I subtract 0 from x? No, so we got x minus 0 squared plus y minus 1 squared is equal to 25. And so now we're going to figure out what our h and k are. So our h is 0, k is 1. Right? Our r squared is 25, therefore our r has to be 5, right? Because the square root of 25 is 5. So now we have h and k is 0, 1. Plotting my point, I'm going to go 0, up 1. This is my center of my circle. I'm going to have to go up 5, so I'm going to count carefully. 1, 2, 3, 4, 5. There should be a point here. I know that my radius will go 1, 2, 3, 4, 5 to the right, 5 down, and 5 to the left, of course. And then I draw a nice circle as well as I can. It's kind of hard without a... Okay, and that's it. Not bad, right? So that's how we draw our graph circles on a graph using the standard form of the graph, of a circle. Okay? Questions on numbers 1 and 2? Raise your hand now. Okay, cool. So why don't we have you turn to your neighbor. Let's have you discuss 1 till 2 is about number 1. Number 3. You could start this off while your iPads load on your notebooks, okay? So you don't need your iPads right now. Okay, so write down the original problem. We got x minus 2 squared plus y minus 3 squared is equal to 16. We're writing this down in your notebooks right now. No iPads right now, just get them loaded up with the way they're ready. Okay? Okay, let's do this one together. Turn to your neighbor and identify h and k and the radius. Okay, what is your h, everyone? 2. Good. So your h is 2. I heard someone say -2. Okay, it's not -2, it's 2. Okay. What's your k, everyone? K is?
3.
Good. K is 3, right? And then what's our r?
4.
Good. Why did you say 4? There's no 4 in this problem. Square root of 16 is 4, right? So your r is equal to 4. Good. So your center is going to be 2 plus your 2, 3. Okay? We're doing this together. I'm going to work this whole problem out for you. I just want to make sure you're following along. So we're all doing this one together. So now we're going to go to 2, 3 from our center, finding the origin of our graph, which is right here. And we're going to move from 2 up to 2, 3. 1, 2, and then up 3. So your point really should be for the center right there. Okay. Then we're going to graph radius of 4. We're graphing a radius of 4, so we're going to go up 4. Ready to go left 4, down 4, and right 4. Okay, and then we're going to graph a circle. Okay, so yours should look like mine, okay? So I'll give you a moment. Number 4. So let's start this one off together. What's our H and K, everyone? What's your center? 1. Okay, H is 1. What's your K?
3.
K is 3. And then what's your radius? 1. Good, thank you. So your center should be at 1, 3. And your radius is at 1, okay? So I want you to graph this one by yourself now. I'll come around in 1 minute. Can you start graphing your graphs? Or you should have been graphing your graphs. I'll start on the opposite side this time. 15 seconds. Okay, answers up. Okay, so the radius, quiet down, please. We got our radius, our center is going to be -3, -5/2, so you go -3. Now this one's a little bit special because you have to go down 2.5, so we're going to have a point all the way down to here. Okay, that's our center. Now what do you notice about my center point? Is it on a lattice point? Is it on a crisscross point? Eyes up here. Is it on a crisscross point? No. A lattice point? No, it's not. So we have to be very careful. So we said the radius is 4, so watch carefully up here. When you go up 4, you're going to go up by exactly 4. You're not going to end up on a lattice point. So you should have a point right here. And then we're going to go down 4. You should have a point here. Okay. You notice how these radius points are not perfectly on a crisscross point, right? Same thing here. We're going to go right 4. So I want to make sure that my point is 4 to the right, so I want to make sure that it lands in the middle here. Same thing on the left side. And then we draw our circle, okay? And your circle should look like a circle. I saw some like different pictures so far. So, okay. Next one, number 6, last one, okay? 6 all the way through by yourself. There's no talking on this one. Before we start, though, what do you notice that's a little bit weird about this one before we start?
13.
What's weird?
13.
13, right? What's the square root of 13? Do we know? No, but we can estimate, right? So what's the square root of 16?
4.
Good. What's the square root of 9? Wouldn't you agree that 13 is between 9 and 16?
Yeah.
So let's predict about how much what square root of 16 is. 3.7, 3.5. So let's just say it's 3.7. That's okay. So let's just say our radius is going to be the square root of 13, which is about 3.7. Okay? Keep going. I want you to finish up the problem by yourself. No talking right now. Go. Okay, so our center is at 2, -2. You should have a center here. 3.7 to the right, which is almost 4. 1, 2, 3, almost 4, right? So we want to go right about here. Down 3.7. 1, 2, 3, and then almost 4, which is 3.7 right about here. Same thing to the left, and also up. Draw your circle. Okay, and that's it. Thanks, I'm getting better at this, okay? All right, and that concludes this lesson. So,